Hello, I'm Engineerly, and today we're going to try and answer two very, very important questions. Am I a moron for buying a $100 Craigslist CNC router? And is there any utility whatsoever to owning an Inventables X controller? Well, let's get right into it. Alright, it's been about 2 hours. I've spent that entire time cleaning out this shop, which does have a way of getting really messy, and we can actually get started now. Got a spot for the machine in the corner, I'm going to load it in, and we're going to go for first impressions and see whether I really have bought something that's going to be a huge financial burden. Alright, here's the router. It looks pretty nice. There's definitely some problems. I mean, it did include the Posh Colt router, which, if you know anything about CNC routers, almost all of them have that or the DeWalt equivalent. It is missing its collet, but it seems to run pretty smooth. There's not a huge amount of immediate slip on any of the axes. I mean, there's a bit of an issue on Y, where I can feel a little bit of shake, and I'm hoping that's just like a loose bolt on one of these threads somewhere, but I'll hold out hope on that. The wires are in terrible condition. There seems to be some kind of rodent damage on them, but nothing that's going to destroy them. I just need to go over all of them and make sure that the holes are patched, there's not going to be any crosstalk. The table itself is completely destroyed. You can see that they're puffed, coming apart completely. I mean, that's the main sign of this thing's being stored outdoors, really. There's a tiny bit of face rust on the motor mounts themselves and motors, but I think that everything's going to be fine as long as, I rip out this bed and make sure that the wiring checks out, and I'm going to have to sort of tighten everything and kind of see how that goes. But I think this is actually a pretty solid machine. It looks like it's got these big 1/2-inch linear rods that I think are going to be really nice once I can polish them up a little bit and add some oil. I guess really the question is going to be, how much am I going to regret this being my only extra CNC controller? So I guess I'm going to start with the wires and then move on to the bed. Alright, I just finished cleaning up the wiring, and thankfully it wasn't as bad as I thought. It wasn't rodent damage. It was just, I think probably something heavy had fallen on the wire and it stripped the coating off, which means that I needed to add a coating, which I had some electrical tape, but I didn't have to replace any wire or do any soldering. I ended up shortening them and cutting off the connections as well. So all pretty straightforward. I think a lot of people would say that a CNC machine kind of needs to be very complicated, you need a lot of end stops, all this kind of thing. But I don't really think it's necessary. I mean, with a 3D printer, end stops are incredibly important because it needs to know exactly where the machine is in reference to the bed, where you positioned it all, but a milling machine really just needs to know where it is in reference to the stock. And since you have to spend a lot of time adjusting that anyway every time, I think it makes a lot of sense to just go with only the motors and kind of see what happens. I think I'm really thankful. The backlash issue, it seems to just be this. You can plainly see what I mean by backlash. This connection is completely rock solid, as tight as it'll go. In fact, they're actually seized, I can't even loosen them. And you can pull on this lead screw. And you can see that even though the motor is stationary to the frame, we're getting a 1/4 inch or so of movement on that thread. Unfortunately, these hex heads are extremely set in. I'm imagining that Loctite was used when they were first put in, so now that they're slightly loose on the bottom, I can't get them tighter or looser. And so we're going to pull them out. I've seen a lot of different ways to do it. Typically you'd use a screw extractors tool. You would be left-hand threaded. You drill a small hole in the middle of this and then thread that thread into the screw itself, and then as you tighten it, it'll work the bolt loose. But they tend to be kind of problematic. And if you have any problems with the metal, the piece will crack and it'll embed a small piece of really hard metal inside of the screw, making the problem much worse. So I'm going to try something that I've gotten to work a lot before, which is just cutting a slot into it with a little Dremel and then using a flathead screwdriver in that slot to extract it. Well, that job's done. I ultimately had to part that second one like the Red Sea. In fact, you can actually see there's a little bit of residual slotting on the shaft going out of the motor, but I mean, I got it out. I bought the replacements a couple days ago, so we'll be good to put those in when they're ready. I guess this is kind of just a word to the wise, like there really is no super duper clean way to extract anything that's stripped out or completely seized. Penetrating oils can work. Very, very careful application of the proper tools can work, but anything you do can ruin stuff and make stuff worse, so you've kind of just got to be ready to take some L's. But ultimately, I'm pretty pleased with this, and I can actually see the remnants of thread locker in this, so I know what I was fighting against. Alright, on to the next. I think a lot of the hard work on this rebuild is finished. We've had the machine now like 4 or 5 days, and we've got the backlash issue sorted, we've got the wires sorted, we're going to need to get it all connected to the controller, which I think will be pretty plug and play, and we need to remanufacture the bed. But before we do any of that, while it's still, completely disassembled, at least as far as I think it needs to be, we need to clean it really well and re-oil all the ways. There's a few parts where I think it's actually going to be a little tricky to clean, right around the motor mount here for the spindle. I think all of this is going to need to kind of come apart so we can get it really clean. It's very grimy and dirty in there, but once we've got it clean, polished and oiled, we can reassemble it, remachine the bed, really fully assemble it, and I think we're pretty much good to go. It's finally bedtime. Now we need to make a piece of wood that will incorporate slots so that we can have these T-nuts, special T-bolts I guess, stuck in there and use it to hold down stuff while we're working. Now, I think typically you take a bare piece of MDF and just set it on the machine once it was finished and assembled and then cut them out with the CNC itself, but I'm actually going to cheat because I already have a CNC that works. I'm going to cut it out on that after designing it and then just throw it on the machine so we can get it all working together. I didn't end up filming a lot of the next steps while I was doing them just because they demanded a lot of attention and I didn't think they'd work very well on camera. So to kind of sum it up, I tried connecting the machine up via Easel, which is the company that makes the controller's proprietary CNC control software, and I ended up not being able to calibrate it to the kind of machine that I had here as opposed to the kind that they wanted, the kind they manufacture. So I ended up switching over to Universal G-Code Sender, which was a fairly smooth process. Calibrating the motors took a little while. It needs to figure out exactly how many control signals to send them for each sort of linear distance unit. The only issue came about with the way that the different sort of coordinate spaces interacted with the machine. So to try and put this into as simple terms as possible, there's two coordinate spaces. There's the ones where there's like the physical machine one, which is where it has the minimum it can travel on the machine versus the maximum it can travel on the machine, and so that's what homing switches are for zeroing. So you can move the machine to a known position at the start and then set it. And then there's the workplace coordinate, which is where you have your stock and you want to put it in some unit place in your stock so it can then move around and kind of start the program. And what I didn't realize is that the there's actually an interface between these two coordinate systems that really matters, and it's called G28, and it's the command that the machine sends when it wants to go into a safe position around the stock. And that's not set based on the workpiece coordinates on the actual thing, that's on the machine coordinates. And if you don't have homing stops, those machine coordinates are set at 0, 0 at wherever place the machine is when the controller is turned on. And if your G28, which is set relative to that position, is lower, it means that if you power on the machine when it's hovering just above the stock, it will crash the stock and ruin it. And I'd be lying if I said this had not gotten me extremely frustrated. It took me a long time to figure out this was the issue, and I kept ruining stock. Finally it clicked. And so the workaround I have right now is moving the machine to kind of a known position and then turning it off and restarting it, which artificially sets G28 in a safe position. But it would be a good idea to upgrade and put on homing switches to kind of solve this issue forever, but as it is, things are working well, and I had a little shitpost project I quickly threw together, which I'll show you now. And so, in conclusion, if you have a couple days and you see a CNC router on Craigslist for $100, it might be worth picking up, because that's pretty much the only way to make terrible parody signs a reality on a little engraver.